In this video, we're going to see one of the examples of the applications of the geodesics and Christoffel symbols and tensor calculus, and how should we derive the one of the most famous equations in physics with tensor calculus, which is centripetal acceleration. So I'm going to write the geodesic equation here: d squared x lambda d tau squared plus Christoffel symbol lambda mu nu dx mu d tau dx nu d tau equals 0. So what I'm gonna do, I'm gonna write down the metric tensor for the polar coordinates. G mu nu is 1 0 0 r squared. My g 0 0 is 1. My g 1 1 is r squared, and my coordinates are in theta, which I'm going to show with 0 and 1. So when I write GRR, or I mean G11, and when I write G theta theta, and I want G00, I mean GRR. So what I'm going to do, I'm going to calculate the Christoffel symbol that connects the geodesics to the distance that we're traveling from the center of it. So for that, I need to calculate the 0, 1, 1 geodesic. So it's going to be half G00. This is just the inverse metric tensor, and inverse metric tensor G mu nu is 1 0 0 1 over r squared. And when I write partial nu, I mean partial of G00 partial x nu. So it's just a contraction of it to make it more simple here and use less ink. So I'm gonna write, if I write down all the components here, it's gonna be G1, G01 plus G1, G01. These two are going to go to 0 because G01 and G10 are off diagonal, but minus partial 0 of G11. This is not off the diagonal, this is diagonal. So I'm going to multiply it by negative partial 0 of G11. G11 is r squared, and partial r of r squared is 2r. So I'm going to multiply half times 1 times negative 2r, which is negative r. So the 0 1 1 Christoffel symbol is it's negative r. So now if I go back to the geodesic equation and plug in 1 for lambda, 2 squared x1, because I want to relate it to the radius and radial distance from the center of it. I'm going to use 1 as lambda because dx1 is dr, plus 0 plus 0 dx1 d tau and d tau. So, I'm gonna use 0 as lambda because r defined here is 0 and theta is 1 or is 0. And I'm gonna choose 1 for mu and nu because in the other cases, if I do write the summation notation explicitly, all the other Christoffel symbols are going to go to 0. So in this case, the only non-zero Christoffel symbol for this case is 0 1 1. So I can write d squared r d tau squared is minus 0 1 1 Christoffel symbol is r times d theta, because x1 is theta, d tau squared is 0. d squared r d tau squared is r times d theta d tau squared, the whole quantity. Now I want to review and say that velocity is theta prime, or d theta over d theta, times r. So the theta prime, or d theta over d tau, is v over r. So I'm gonna replace v over r here, r times v over r squared, d squared r d tau squared, d squared r d tau squared now is gonna be r v squared over r squared. Now d squared r over d tau squared is v squared, so let me write it clear, v squared over r. And the second derivative of distance is acceleration. Thus I can say that centripetal acceleration is v squared over r. And that is one of the ways that we can derive the centripetal acceleration. And in this case we use tensor calculus and differential geometry. Thank you for watching this video. If you have any questions, please let me know in the comments, and I'll see you next video.